Let's go. All right, so now we're going to talk about a different type of form. It's called an irreducible quadratic, which means it's not factorable. You know, like x squared plus 1, you can't factor it. But that's not linear. When I say linear, that means there's no squares, there's no square roots, it's just x's plus something. That's all we've dealt with so far. X is plus nothing, x is plus 7, x minus 2. But now we have a square, and you cannot factor it. So anytime you have an x squared plus a number, it's non-reducible or irreducible. So let's see this. Now, we're not going to do this problem. Notice there's not even an integral on it. But it's how we're going to break it down by the partial fraction decomposition method. Now, we have a linear factor. You see the linear factor? That's x minus 2. That's no big deal. We know how to deal with that. That's going to be some a over x minus 2. But here, that's what we call an irreducible quadratic. It won't break down. So the x squared plus 1 goes down below, but we don't just write a b. We don't just write a b. We're actually going to write this in as b times x plus c. Now, let's just think about something. If we can keep this straight, it's not going to be that big of a deal. That's degree 1. Just a constant is degree 0, so the denominator is 1 degree bigger than the numerator. This is a second degree polynomial. The numerator is a first degree polynomial, meaning that we always have 1 degree less up top than we do down below. Now we move to our last one. Again, we have an x squared plus 4. Thus, we have an irreducible quadratic. If that was x squared minus 3, shoot, we could break it down into x minus the square root of 3x plus the square root of 3. We'd have no issues and we could run right through it. So now we're going to write it as, just keep going with the letters, dx plus capital E. Don't use a small e because that has meaning. This is what we do with irreducible quadratics. And just a little bit of a help for you before we get into it. For some constant. Okay, so for example, maybe this is 1 over x squared plus 4. Maybe we end up with this. I just want you to know, here's the general form up top. This is 1 over a times inverse tangent of x over a plus c. You might want that memorized. Maybe you already have it memorized by going through and doing other pieces of work. But, yeah. So it shows us that, well, what's our a down below? Our a is 2, not 4, but 2. So this is 1/2 inverse tangent of x over 2. Now, as a student, I didn't memorize this. I just did it. I just did the gosh darn problems. We've been doing them so often, and I'm not very good at memorizing stuff. I was much better as a process. So I didn't memorize it, but possibly you want to, because this is going to pop up at times. X squared plus a number, you better know how to deal. So, all right, let's run through and do a problem. And I'm going to skip a lot of the algebra in this, because we're just trying to get the process down. You need to practice the algebra. Shoot, I know I need practice too, but interest of time, I don't want to be giving you 20-minute videos. I know I wouldn't listen to them if they were that long. All right, so this denominator, again, let's work aside. Outside of the integral. So we can factor up this denominator pretty simply. You can see you can just take out an x, and then we're just left with x squared plus 4. All right, let's go. Let's go. So we know that this is going to become some a over the x value, right? Because that just gets an a. But then we're going to have that x squared plus a number. So that means we get a bx plus c. So we're going to be solving for 2 separate variables on the right. So let's now multiply by the denominator. So we get 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c times x, right? Because we're just multiplying by x times x squared plus 4. So like that cancels out, just leaves you with the x. The x cancel out, just leaving you with that. Okay. Now we're in another situation where if you could plug in x equals 0, we can solve for c. No, we couldn't. We have to equate our coefficients again. So let's bring everything through. Okay. So we get 2x squared minus x plus 4. Okay, I will speed up. Well, maybe I won't. I don't know. So we can see we can get a right away. So let's just put this in terms, all the x squareds together. We get a plus b is equal to, or times x squared. We get cx, that's the only one with just an x on it. And then we get plus 4. A is equal to 2x squared minus x plus 4. Which means that a plus b must equal 2, right? 2, a plus b. We got our c is just equal to -1. That's pretty convenient. That -1 that's hanging out there. And then we have 4a is equal to 4. So this one isn't so bad. Therefore, a is equal to 1, c is equal to -1, and then we plug in 1. 1 plus what equals 2? B is equal to 1. Hey, a is 1, b is 1, c is equal to -1. That's not bad. So let's go back and let's solve our integral. So we're going to end up with 1 over x, right? We're just plugging in a 1 there. We're going to plug in a 1 for our b, and then we're going to plug in a -1 for our c. So then we have 1x minus 1 all over x squared plus 4. Woo! Now we can start doing some integration, right? Let's go. So this becomes, I think we need to do some algebra first. Wait a second. I don't think I can just integrate this straight up. And this happens a lot. I'm glad that we're doing this problem, because this is you got to break up the numerator to make this work. So this is the integral of 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4 dx. And I actually want to do these separately, because the center term is going to require u sub. So our first one, natural log of the absolute value of x. No problem. Minus, well, we're going to use that rule that we learned from before, that our a is equal to 2. So this must be, sorry, I'm putting the last term. This is 1/2 inverse tangent of x over 2. Now we can deal with that center integral, where we need to do u sub. So u is equal to x squared plus 4. Du is equal to 2x dx. So we get 1/2 du is equal to x dx. Now we can go through and solve. So this is the integral of, the u goes down below for our x squared plus 4. And then instead of x dx, we're going to get 1/2 du. So we're going to end up with 1/2, the natural log of the absolute value of u plus c. But u is just x squared plus 4. Now we can write in the rest. And there's our solution. Oh, PFDs. Oh, they're long and tedious, but they're actually not tough. They're not tough. You may not like them. You may groan about them. I know I did as a student. Like, oh, PFDs. But they're not actually that tough. They're just long. And it's tedious. And yeah. Okay. I'm going to do one more video. We're not even going to solve this problem. This time I promise we're not going to solve the problem. It's a scenario I want you to see, but I don't want you to solve. It's way, way, way too much. I just don't want to do it, all right? So, and you don't want to do it either. So, all right, I will see you in the next video. And then we'll move on after that. I don't know what we go into next. What do we go into? Now I'm babbling. I do that. We'll go into some strategies. All right, see you.